Welcome to this quick video tutorial on Golaem in Houdini using USD. My name is David Raymond, lead crowd artist at Rodeo FX Montreal. First, a quick word about what is USD. USD stands for Universal Scene Description. USD provides a rich toolset for reading, writing, editing, and rapidly previewing 3D geometry and shading. I encourage you to read the official Pixar USD documentation, as it is a quite extensive and powerful software. The purpose of this video is to show you a quick overview of a specific feature of USD, which is its layering and composition features, and how it can be useful for Golaem crowds. Alright. Let's start this demo by setting us up. In the upper left corner, you will see a drop-down menu that is your currently active desktop. Let's change that for the Solaris one. It will expose all the data that we need properly. Alright, so if you configure your Houdini to load the USD Golaem plugin, you should just be able to drop a file node, browse to your file, and it should load your cache in Houdini in a USD format. If it's not showing up, and the scene graph tree right here that lists all your entities and their attributes doesn't show up, or this node errors out, it's probably because your configuration is wrong somewhere, and you should go back to the Golaem documentation to fix it up. Alright, let's dive right in. So what we will try to achieve here is simulating the dresses of those dancing girls. And by the way, if you want to follow along, all those assets are available at mixamo.com. They are free and ready to use. This node right here constitutes our base layer, similar to Photoshop. And we want to create another layer from that base that will be containing the deformation or even new meshes that we want to add to it. So let's rename it properly. Let's call that Golaem base layer. First, we will have to isolate the characters that we want to simulate, which are our dancing girls right here. Then we will simulate the dresses using a quick and easy Velum setup that I will show you how to put in place. And then we will prepare and write down just the necessary deformation data to a new layer that will be combined with the base layer. Finally, we will write down a composite USD file that lists both our base layer and the cloth layer together to be used for rendering or anything else we want to do with them. So let's move on with the isolate part. To isolate the characters using attributes, I recommend you to do so using a Wrangler node. That way you will have a better control over what you are doing. The first thing you will have to set is the filter pattern that indicate on what USD nodes to run the code over. In our case, we want to run our code over all the entity nodes because they are the root of each characters, and also they have the attributes that we want to query. Once the filter is set, we want to write a simple if statement running a USD set active function to disable any characters that don't have an attribute GLM entity type set to 1. So let's move on to the core of this quick demo, the actual simulation. Normally you would want to set a recipe for your CLAT sim on one character first. That way it will be faster to iterate, much simpler. And yeah, so let's do that here. What I did here is modify our Wrangler node to just check on the entity ID instead of the entity type, and I just specify to just keep the 1001 character. This submodify node is where the simulation is done. This sets you up in a geo context where you will be able to drop all the nodes you need to simulate properly. But before we look into that, we need to set it up a little bit. There is 3 things to configure on this node before you dive in. First, you will want to activate in the import from subtab the perform layer break before import option. This is the most important setting and where the magic happens. This option tells Houdini and USD to only save in the layer that will come downstream what was modified in this node, meaning the addresses. The second thing to adjust is in the export to subs tab, and is the time expression right here. Normally it is set to $rf start, and we want to change it to $ff so it evaluates over time. And the last thing is to set the traversal mode to component instead of not traversal. It's just to tell Houdini and USD that we will modify inside here actual geometry and not just transforms or other things like that. Yeah, so let's move right in. Alright, so in the submodify node, the first node that you will have to drop is the USD unpack node, and set it in the polygons mode. This will give you access to the actual geometry data. Before that you would see something like that, just to point to primitive to packed USD, and after the unpacked you will see the actual points, primitive, vertices, and polygons, and all the attributes. Then I create a ID attribute for safekeeping, because we will isolate and combine stuff, and we want to make sure we are able to recover the point order in the end. I then proceed to separate the address from the rest using 2 blast nodes, one just isolating by the name attribute the address, and the inverse for the remaining of the geometry. Under the isolated address, I paint a Velum attribute named stretch stiffness that will control the constraint to animation. I paint around the hip area to make sure that that part follow animation. Alright. Under the paint, I subdivide the dress mesh. This is only important if you have a mesh that is too low res to simulate, like you can see here. This will ensure that you have proper folds and make sure you have a quality simulation. Then Velum insists to have a valid ID attribute, so I reset the ID attribute here. This node right here is simply the Velum configure cloth that you can get from the tab menu. I did not change a lot of stuff in there. Mainly I set the thickness manually, made sure it matched the animation, and adjusted the bend stiffness. This node right here is what's constraining the hip area that we painted to the animation. So it's a Velum constraint node that is set to pin to target. You will have to change the pin to animation options to soft, both of them, and activate match animation. This part right here is the stiffness, the actual value to the constraint. By default you will see it like that. Change this option right here on the right to scale by attribute, and make sure that the attribute name here match what you painted in your paint node right here. At that point you have the Velum solver node. I did not change anything in there, but basically this is where you will set the sub steps, the forces for the gravity, and yeah, actual simulation options. In the right input right there, you will find you will have to plug in there the collision objects. For that purpose I just took the nut dress geometry, merged that with a ground plane, and I just plugged that in there. So at that point, if everything went well, if you play it, you should see an animated dress, a simulated dress actually, like that. You should cache it out using a file cache node. Never use a live simulation, especially using a point deform. You are asking for trouble if you're not caching it first. So there you go, you have a dress that is moving. Now comes the part where you will want to deform this dress using the simulated one. So to do that, you use a point deform node. This node, or actually I use a point deform node. I'm sure there are other methods out there, but I kept it simple. So the first input is the mesh to deform that should be frozen into the rest pose. So this dress right here. But there's a little bit of a complication here. You cannot just freeze it and hold the first frame, because USD have an attribute in there that is called USD X form, that is basically the centroid of the animated dress. So I froze the actual transform, but I copied over the animated attribute back on the frozen mesh to not break anything with USD a little bit later on. And then for the other two inputs, you have the rest, non-moving simulated rest, and the actual simulated one on the third input. Then at that stage, you should have the low res dress deformed by its simulation. And then as a last step, I have a cleanup node that only keep the point position and the USD X form that we saved earlier and the normal, and delete everything else to save on caching space. And yeah, that's about it for the simulation part. Alright, let's move back to the stage area. So now it's time to simulate our dresses on all the characters. How I've done it is right click on the recipe that we did here and create a reference copy of that node. This there you go, essentially create a copy that all the channels and the content is referenced to that node. I just plug it right here under the simulate null. The only thing I changed is to make sure to reset this expression to the default one, so it, you know, consider all the geometry that is coming from the input. This is essentially what it's saying here, just take all from the input. And yeah, we are ready to simulate. If we dive in, everything should work as it did on the isolated character. The thing that is cool proceeding that way is that the paint attribute right here will work on all the characters, so you don't have to repaint every single dresses. It will understand that those geometry being the same, use the same paint for every dresses. So let's verify that the Velum solver node still evaluate properly. Trying to simulate that. As you can see, everybody is moving and simulating independently. So we'll just cache this out, which will look like this, and do the cleanup, and there you go. So we have our simulated dresses back on the low-res version, original version, and everything is moving properly. Alright, so it's time to go back to the stage area and write everything that we've done back into a layer. So to configure a new layer, you have to use a node that is called configure layer. First attribute that you will have to set is the safe path, where you want to write down on disk the layer, and also you will want to flatten everything that you did inside the submodify node to make sure it write it down properly. Alright, once it's done, you will notice in here that there's no right button or anything like that. The actual data won't write at that level. It will write once you will use the USD wrap node to write down the composite USD file that is basically this layer and this layer together. So to do that, you use a merge node. You just take the base layer, that is this simulation coming from Maya, this layer right here, plug together that, and you will see here that the dresses are now simulated. And this is essentially just taking that, looking at what we did right here and applying the point position modification to the dresses and the dresses only. So once you're ready, you just pop up a USD wrap node and set the output path of the composite USD file. Make sure your frame range is good and save it to disk. Let's do that. Save to disk. It's writing its stuff up. There you go. So now the layer file is now written to disk. If we take a look at it, you will see that all our dresses are stabilized from the hip at the origin of the world, and there's no color anymore. There's only the data that we saved onto the layer. There's nothing else, and this is merged with that as an additive or a combination of the two. And yeah, so basically we have done our job here, and this USD node essentially just written to disk a simple text file that lists this layer path, this layer path, and how to combine them together, which is basically just a basic combine. Load that file first, load that file in second place, and just addition the changes together. So if we take a look at our combine file with a file node like we did at the beginning, and just reference a path right there. So this file right here is the combination of the two. So we can pass over or publish or use your pipeline to just push that file down the pipe, and you will have your crowd simulation ready to render. Alright, so this concludes our little tutorial. I hope you find that interesting. Basically, you can I showed you the cloth simulation part of the thing, but you could easily override the air meshes, remove actually the air meshes and replace them with actual air simulation, bake that into a layer, and you will have your crowd characters with air simulation just on top of it. You can do whatever you want with them actually at that stage. Just keep in mind that each time you remove a mesh or change a mesh from the actual original crowd simulation, you bake a little bit that mesh. So if you take over the entire crowd, it's the same as if you would bake the entire crowd. So keep that in mind. It's good for small modification like that, but on a large crowd, it doesn't save that much space. Yeah, so yeah, Thanks for listening.